Somewhere beneath East Africa, something is pulling the continent apart. Not with an explosion. Not overnight. In September 2005, the ground near a village in Ethiopia's Afar desert tore open in front of the people living there. In just 10 days, a crack over 35 miles long ripped across the desert floor, in some places widening by more than 26 feet. Locals said the earth roared before it cracked. Scientists later confirmed what it looked like, a piece of Africa trying to become an ocean. This is the East African Rift, and researchers now say it's one of the only places on Earth where you can watch a continent break apart in real time. The question isn't whether it's happening. The question is, what happens to the 300 million people living on top of it? Stretch a map of East Africa in front of any geologist, and they'll trace the same line. A valley system running nearly 3,000 kilometers, cutting through Ethiopia, Kenya, Tanzania, and Mozambique. It's called the East African Rift, and it's not a canyon carved by water. It's a wound in the crust itself, torn open from below. For decades, scientists suspected the region was slowly stretching, but suspicion isn't proof. What they needed was to catch the process in the act. That happened in Afar. Afar sits at a genuinely strange address on the map, the meeting point of three tectonic plates, the African, Somali, and Arabian plates, all pulling in different directions at once. It's one of the hottest, lowest, most geologically violent places on the planet. Parts of it sit more than 100 meters below sea level. And in 2005, GPS stations and satellite radar caught something no one had measured this precisely before. The ground wasn't just cracking, it was moving, continuously, in small, measurable steps. Today, GPS monitoring shows parts of the rift widening at roughly 6 to 7 millimeters a year, about the speed your fingernails grow. That sounds small? It isn't. Run that number forward, and in 5 to 10 million years, scientists predict ocean water could flood in and split the continent, creating a new coastline where Ethiopia, Kenya, and Tanzania now sit inland. Africa's next ocean is already under construction. Here's the part most people get wrong. They picture two puzzle pieces just sliding apart. The real mechanism is stranger, and it starts almost 3,000 kilometers beneath your feet. Deep in the mantle, a column of abnormally hot rock, geologists call it the African superplume, has been rising for millions of years, pressing up against the underside of the continent like a fist pushing on a blanket from below. That heat does two things. It weakens the crust from underneath, and it pulls the surface outward in opposite directions, like taut dough being stretched from both ends. At first, nothing visible happens. The crust just gets thinner. Then cracks appear, what geologists call normal faults. Blocks of land drop down between them, carving the dramatic valleys you see across Kenya and Tanzania today. Where the crust thins enough, magma finds a shortcut to the surface. That's why East Africa is home to some of the most active volcanoes on the continent. Mount Nyiragongo, Oldoinyo Lengai, Erta Ale, each one a pressure valve for a planet stretching itself open. And where rock doesn't melt, it breaks. Small earthquakes, most too weak to notice, ripple through the region constantly, each one a tiny signature of rock adjusting to enormous, invisible force. Individually, none of these signals prove much. Together, the faulting, the volcanoes, the earthquakes, the millimeter by millimeter GPS drift, they form a single, undeniable picture. Africa isn't just old, it's still being built. Here's what geology textbooks leave out. This isn't an empty desert experiment. Roughly 300 million people live along or near the East African Rift. Some of that is a gift. Volcanic ash has enriched the soil across the Kenyan and Ethiopian highlands for millennia, among the most fertile farmland in Africa. Rift lakes like Tanganyika and Malawi hold roughly a sixth of the world's unfrozen fresh water and feed fishing economies for tens of millions of people. But the same forces that built that fertility can turn violent with almost no warning. In May 2021, Mount Nyiragongo erupted without the kind of warning authorities expected. Lava reached the edges of Goma, a city of over 1 million people, in hours. At least 32 people died. Roughly 400,000 residents were evacuated in a single night. It's the same mechanism driving the slow-motion rift 3,000 kilometers away. just compressed into hours instead of millennia. That's the paradox scientists keep circling back to. The rift operates on two clocks at once, a continental clock, ticking in millions of years, and a human clock, where a single eruption or earthquake can end lives before anyone finishes reading an alert. Which is exactly why the monitoring stations in Afar matter far beyond Ethiopia. Every GPS reading, every tremor logged, feeds models that help predict eruptions and earthquakes days or weeks out. Not perfectly, but better than a decade ago. In a region this populated, that difference is measured in lives. Here's why geologists across the world have their instruments pointed at East Africa. This has happened before, and it built the map you already know. Around 200 million years ago, every continent on Earth was fused into a single landmass, Pangaea. The same rifting process now visible in Ethiopia tore Pangaea apart piece by piece. The Atlantic Ocean exists because Africa and South America once split exactly the way East Africa is splitting now. The Red Sea, just north of Afar, is the next stage of this same story. A rift that already succeeded, already flooded, already became open ocean roughly 5 million years ago. Iceland sits on a mid-ocean ridge doing the same thing beneath the Atlantic right now, just underwater, invisible to satellites watching dry land. East African Rift is the rarest of the three. A rift you can stand on, mid-transformation, on a schedule short enough for one research career to watch it evolve. That's why this patch of desert in Ethiopia has become one of the most heavily monitored strips of land on Earth. It isn't just a local story. It's the closest thing geology has to a live demonstration of how oceans are born. So will Africa split in two? Yes, almost certainly. Just not on any calendar that matters to us. Models point to 5 to 10 million years, give or take. No one alive today, and no one for roughly 200,000 human generations after us, will see the ocean that forms here. But that distant timeline is not the point of this story. The point is what the rift proves right now. The ground under our cities, our farmland, our maps. It was never actually still. It only looks that way because human lives are too short to watch it move. Every mountain range, every ocean, every continent you've ever seen on a map was built by exactly this process. Slow, relentless, and for most of Earth's history, completely invisible to anyone living through it. East Africa is the one place where that invisibility has broken down. Where you can watch, in a single human lifetime, the opening seconds of a story that usually takes eons to tell. The Earth isn't broken beneath Ethiopia, it's working. If you want to understand the next fault line before it makes headlines, subscribe. Because this isn't the only place on Earth quietly rewriting the map. There's another one, and it's underwater. That's next.